Hello everyone, I'm Huang Zhenyu. Today I will be presenting my course project, the CloudShop e-commerce platform technical solution. This video is divided into 3 parts. The first part is project architecture and design rationale. The second is hands-on implementation in the AWS Academy Learner Lab. The third is learning reflection and challenges. Part 1. Project architecture and design rationale. CloudShop is a fictional e-commerce platform designed for small to medium-sized online merchants. We choose to build it entirely on AWS cloud services for 3 main reasons. The first is elastic scalability. E-commerce traffic fluctuates significantly. Cloud services can automatically adjust resources based on load, ensuring performances while controlling costs. The second is high availability and security. AWS provides multi-AZ deployment, VPC network isolation, security groups, and more to ensure system stability and data security. The third is cost efficiency. The pay-as-you-go model is ideal for startup, eliminating large upfront hardware investment. We used the following core AWS services: EC2 to host the web application, VPC to create an isolation network environment, RDS to store product, user, and order data, ELB plus auto-scaling for load balancing, and automatic scaling, CloudWatch for system performances monitoring, EBS for persistence storage and backup. Part 2. Hands-on AWS implementation walkthrough. Now, let me walk you through the key configuration steps we performed in the AWS Learner Lab. Task 1. IAM. We used the predefined lab role for all permissions, simplifying access management and adhering to the principle of least privilege. Task 2. VPC and EC2. We created a VPC spanning 2 availability zones with public and private subnets, Internet Gateway, Net Gateway, and configured a security group to allow HTTP and SSH. The EC2 instance was launched in a public subnet as our web server. Task 3. Web feature development. Based on the Amazon Q developer activity, we developed a simple product display page and deployment it on EC2. The page is accessible via the public IP address. Task 4. Monitoring and instance upgrade. We enabled termination protection, upgraded the instance type, and used CloudWatch to monitor CPU, network, and other metrics. Task 5. Storage expansion and backup. We created and attached an additional EBS volume to the EC2 instance for application data storage, and took an EBS snapshot for backup. Task 6. Database integration. Due to permission restrictions in the Learner Lab environment, we were unable to create an RDS instance However, we fully designed the database deployment, including subnet groups and security group roles to ensure secure access from EC2. Task 7. Auto-scaling and load balancing. We created an AMI for the configured EC2 instance, set up a launch template and auto-scaling group, and use an application load balancer to distribute traffic for high availability. Part 3. Learning, reflection, and conclusion. Through this project, we not only gained hands-on experiencing with core AWS services, but also deepened our understanding of cloud architecture, advantage in scalability, security, and cost management. Key challenges include permission management while lab role, simplified access. It also restricted concern certain action like RDS creation, network configuration, designed VPC subnets, route tables and gateways required careful planning, monitoring and optimization, learning to use CloudWatch effectively to identify performance bottlenecks is an ongoing process. Overall, this practical project provides us with a real-world understanding of cloud computing applications and laid a solid foundation for future cloud-related work. That concludes our presentation of the Cloud Shop project. Thank you for watching, and we appreciate our instructor guidance throughout the course. The full project report has been submitted, and the video link is included in the report.